Hello friends, once again I welcome you all to our channel. Today we are going to learn about the graphs, like which graphs gives which slope and what does the area under that graph gives. First of all, let's talk about this distance time graph. As we all know, distance is a scalar quantity. So distance and time is also a scalar quantity. So the slope which would be produced in this graph would be also a scalar quantity, and this would become a speed. Now let's talk about displacement time graph. Here, displacement is the vector quantity, whereas the time is the scalar quantity. So the slope of this graph would produce a vector quantity. We saw that in the distance time graph, it gives speed. So the scalar version of the speed is known as the velocity. Okay. Now let's talk about the third graph, which is velocity time graph. And again, we have velocity time graph because here we will study about its slope and the area under which it gives. So let's talk about this slope. The slope it gives is known as the acceleration. Okay, and the area under this graph gives the displacement. Okay, now let us get to know that how can I say that the slope gives the speed, and here the slope gives velocity, here the slope gives acceleration, and here the slope, not the slope, the area under it gives displacement. So first we were to get to know about graphs. This is called the x-axis and this is called the y-axis. Okay, so let's talk about here. If we take this as the angle theta, so the slope is the value similar as the tan theta. Okay, if I extend it, then tan theta is equal to perpendicular upon base. So if I extend this to here, so it will produce me tan theta equals to slope equals to P by B. Now what is P here? So here the P is the y coordinate and here B is the x coordinate. Same same things occur in all the graphs. For example, if I take the example of the distance time graph, here, uh, here got to know that tan theta equals to slope, which was equivalent to y upon x. And this again becomes in higher classes as the formula as y2 minus y1 upon x2 minus x1. But to know this much is efficient to study. So in the case of the distance time graph, y coordinate is the distance and the x coordinate is the time. So if we write the unit, then it becomes speed. Now let's talk about the second one, displacement time graph. Slope equals tan theta equals P by B. Here it becomes displacement upon time, and we know that it is known as nothing other than velocity. Okay, now let's talk about this third case. slope equals tan theta equals P by B. So here in what we say, yes, in y-axis it is velocity upon time equals to meter per second by second equals meter per second square. How can I say that it is acceleration? Because in definition of acceleration we have read that it is the rate of change of velocity. Now this is a special case, the fourth one. Here we have to find the area. We can observe that the geometry so formed here is in the shape of rectangle, but always it won't be in the shape of rectangle. Now to find the area of this rectangle, we know the formula: area is equals length into breadth. Area of rectangle equals L into B. Okay, so what is here L? Length we will take as this. Length we have taken as the x coordinate and breadth as the y coordinate. And we took time in the x coordinate and we took velocity in the y coordinate. So now by unit matching s into meter per second, this gets cancelled, so we get meter. Now it is the time to judge whether it will be distance or displacement. Okay. Now how will I say that it would be distance or displacement, because both have their unit as meter. So now to judge that, I earlier only said that velocity is a vector quantity, whereas time is a scalar quantity, and the product of vector and a scalar is always a vector quantity. So among these, displacement is only the vector quantity, whereas displacement is scalar quantity. So the area under velocity time graph gives the displacement. Okay, so in the next video I will talk about some other important graphs and tell in which graph what would be the velocity and many things. So for today this much only. Thank you. Let's meet in another video.